In Kowloon and the New Territories, demand for electricity increases significantly every year. To meet this commitment, the supplier relies not only on generation and transmission capacity above peak demand level, but upon faultless internal communications. The China Light and Power supply area is fed from a number of modern power stations like this one at Castle Peak. In upgrading its communications network by a fibre optic system, linking its Hong Kong installations with those in China, the company had three main options. Underground lines were ruled out by the difficult terrain, low-lying areas subject to flooding, alternating with steep rocky hillsides, and the many industrial and residential developments that would be encountered. Also unacceptable would be the heavy plant deployment and the lengthy transmission outages involved in installing new earth wires with integral fibre optics onto the 400 kV overhead system. The chosen solution was to wrap the fibre optic cable around the existing earth wires. After research into similar projects overseas, China Light and Power, with main contractors Balfour Beatty, Sumitomo Electric Industries joint venture, and the manufacturers of the Skywrap cable and installation equipment, Focas Limited, agreed on the installation of a 12-strand fibre optic cable. This followed crucial investigation by the joint venture company into the effect of increased weight and wind loadings on a wrapped earth wire, a vital consideration in typhoon-prone Hong Kong. Focas personnel were brought in to demonstrate the wrapping machinery and train CLP staff in its use, in both deployment and recovery mode. CLP, in its turn, instructed the Balfour Beatty linesmen in safety procedures to be observed on the towers. Installation of the system began in February 1990 and was scheduled to coincide with CLP's planned outage program. Before the wrapping process could start, aircraft spherical warning beacons giving indication of the presence of power lines had to be removed from the earth wire. To maintain safety, the same number of spheres, but of smaller size to avoid excessive weight, was added to the earth wire of the adjacent circuit on the other side of the tower. Petrol-driven tugs with radio control systems are hoisted to the top of the tower. The fibre optic cable, capable of installation on long spans, arrives in a cassette containing two drums mounted back-to-back and holding up to 2 kilometres of tightly wound, jointless cable. The yellow tape marker indicates the centre point. The drums are separated, and each one is mounted on a wrapping machine arm. The spindle passes through the drum and is securely locked. The drum is counterbalanced with weights, and an automatic device for adjusting cable tension is set. With great care, the wrapping machines are then hauled up to join the waiting tugs. The cable's outer casing is specially toughened to withstand pecking by birds, and has been found highly resistant to the temperature rise caused by lightning strikes and fault currents. A simple coupling links the tugs to the wrapping machines. The tug's two-stroke motors are started manually, and the two assemblies proceed outwards from the launch point in opposite directions, paying out the cable that links them. Radio control from the ground adjusts the speed of the tugs. The front roller of the wrapping machine moving along the earth wire is geared to rotate the machine body and cable reel, thus paying out the cable in a spiral around the earth wire. The rate of progress is normally about 1 metre per second. On spans greater than 200 metres, a self-regulating counterbalancing system on the spinning arm compensates for the depletion of cable on the drum, keeping the whole unit in balance. On the next tower, linesmen prepare a jib lift to transport the machine and its tug around the top to continue its journey. The tug weighs 45 kilos, so manhandling it to its new location is no easy proposition, even for the Indonesian linesmen, who are known and respected for their strength and agility. The tug's drive rollers rest on the earth wire. The safety strap is secured. The operation of a handle raises or lowers a tension roller. This governs the grip exerted by the drive rollers onto the wire. The wrapping machine, which with a full cable drum weighs 60 kilos, is swung over by the jib arm. The whole assembly starts the next leg of its journey. The wrapping of the fibre optic cable onto the 400 kV earth wires is a simple and elegant method of upgrading communication systems in a short time frame. There is no disturbance to overhead equipment, no adverse effect on the earth wire, no need for heavy-duty lifting and winching gear. There is easy access for repairs and considerable saving in costs. In this project, China Light and Power and the main contractor planned that only the circuit affected by the wrapping process be switched out. The others remain in service. They are live. The next tower is a planned splice location. The tug is lowered to the ground, and preparations for cable splicing begin. The cable drum is unlocked, and the remaining cable spooled off. The wrapping machine follows the tug down to ground level, from where a plastic conduit rises to the top of the tower to receive the free end of the fibre optic cable. A clamp is fixed to the earth wire, with two flanges attached to grip the end of the conduit. Two layers of protective plastic sheathing are applied to the cable at its point of entry to the conduit to prevent abrasion or bending. Jointing of the fibre optic cables, known as splicing, takes place in a specially equipped van and is the most critical part of the whole operation. The process is monitored continuously by a field engineer at some distance from the splicing van. Each fibre is cleaved with precision to obtain a clean cut with no irregularities. The fibres to be spliced are then butted together under automatic control. The join is achieved by arc welding. Monitoring determines whether any signal loss at each splice, measured in dB and seen as a step in the waveform, is within tolerance, and a copy is printed out as a permanent record by which to assess the future performance of the system. The spliced fibre optics are sealed and dressed into a protective metal box. The box is secured to the tower at a level easily accessible by engineers and repair technicians. Any excess cable is wound round the splice box. A weatherproof galvanized hood encloses the entire unit. At Castle Peak, China Light and Power engineers conduct tests on the first phase of the new communications network. There is detailed examination of every part of the system, the splices being subject to the most searching scrutiny, including, once again, the retention of hard copies of their performance figures at installation. CLP's new telecommunications network has enormous potential beyond in-house data exchange by fax and telephone by computer linkage and video conferencing. With inbuilt telemetry, new transmission equipment, switchgear and substations will come under remote surveillance through the fibre optic system, giving early warning of maintenance needs, and so guaranteeing uninterrupted power supply to the consumer. The lines of communication are open. The flow of information through them will reinforce China Light and Power's unbroken promise to supply electric power when and where needed.